Every morning, these materials are collected for the ultimate test, the hydraulic press.
The team is crucial in separating the materials. Everything from glass to metal pipes must be sorted before moving down the line.
The materials move steadily along the belt. We are now tracking the glass cube as it approaches the intake for the next phase of the manufacturing process.
From the darkness of the intake tunnel, the scrap is delivered to the sheer power of the hydraulic press, where it will be compressed into oblivion.
As the cubes exit the synthesis chamber, they arrive at the receiving station for meticulous inspection.
Ensuring precision is key. This detailed examination prevents defective units from compromising the final build.
The marked objects proceed in single file toward the preparation unit.
Here we see the automated alignment sequence. The pipe is positioned perfectly upright, ready for the diagnostic laser scan and transfer.
The staging platform activates, moving the materials with precision. The metal pipes, glass cubes, and rubber blocks.
Our patented merging technology ensures optimal flow efficiency, allowing diverse objects to converge without disrupting the organized sequence.
Speed is everything, through the gauntlet of sensors and into the vast expanse of the main line. We don't just build the future, we accelerate it. These parallel conveyor systems ensure a constant flow of components to the hydraulic presses, maximizing efficiency and throughput.
The system routes materials dynamically. Metal is directed to the heavy press, glass to the precision press.
Once the pipes reach the loading platform, the massive press engages, ensuring uniform strength and durability for the final product. The components are rapidly elevated to the testing floors, ensuring a seamless workflow as they are delivered. With the specimens aligned, we transition to the compression sequence. We now begin the crushing stage. The hydraulic head is making contact with the copper specimen. The press head makes first contact, deforming the pipe. As the hydraulic pressure intensifies, the force application. The press head makes first contact, deforming the pipe. As the hydraulic pressure intensifies, the force application.
Here we see the full compression force applied to the copper pipe, causing it to collapse and flatten into a dense disc. As the press retracts, the pipe is revealed completely flattened. Next, we examine the structural integrity of the glass cube.
The key challenge with materials like optical glass is their high compressive strength compared to their tensile strength.
As the hydraulic press gently touches the glass cube, the fracture initiates.
The glass cube begins to compress under the immense pressure of the hydraulic press. The resulting shatter in stunning.
The elasticity test begins now. As the press descends, we monitor how the rubber block reacts under
extreme pressure, the rubber block demonstrates remarkable resilience, deforming dramatically but maintaining its structural integrity.
The hydraulic press has fully retracted, signaling the transition to the cleanup stage. The debris must be cleared efficiently for the next cycle.
As part of the initial cleanup, all metallic debris must be cleared from the press base and deposited into the graded collection channel.
As the debris moves along the conveyor, the magnetic separator pulls the metal upward, separating it cleanly from the glass and rubber materials.
Effective dust control is essential. Our high-powered vacuum system extracts even the finest particles directly from the
Here we see the heavy-duty conveyor moving crushed glass, metal, and rubber towards the automated suction system.
The floor collection system efficiently moves the crushed debris away from the main press area towards the recycling facility.
The heated airflow across the conveyor dries the cleaned fragments before they reach the sorting bins.
The rotating drum utilizes powerful water sprays to effectively separate dust and residue from the valuable materials.
With the debris now cleaned and separated, the forklift ensures a smooth transition to the recycling phase.
The sorted material is now moved to the secondary processing area. It is carefully deposited into the large feed hopper of the hydraulic press. The hopper feeding system ensures a continuous flow of crushed metal into the main chamber of the hydraulic press. The reinforced feed chute vibrates at a precise frequency, ensuring a steady stream of scrap metal for the compression chamber. The compression chamber fills with various metal fragments. The heavy doors then seal the load tightly, and the hydraulic...
At peak compression, the pressure exerted exceeds 10,000 psi, compacting 5 tons of scrap into this single, dense block.
As the chamber opens, the solid rectangular block is pushed out, moving onto the conveyor platform for cooling.
As the block enters the shaping stage, the hydraulic press applies immense force to flatten the edges with micron-level accuracy.
Using immense hydraulic pressure, the press head compresses the edges, smoothing and refining the metal structure.
The transfer line bridges the gap between heavy industry and advanced automation, preparing the blocks for the next phase. Integrated processing allows us to combine disparate materials with pinpoint accuracy, ensuring flawless synchronization down the line.
The process begins with thermal softening. The glowing ingot travels along the conveyor, its internal structure.
As the block moves through the coils, the electrical resistance generates intense heat, transforming the dull steel into a glowing. The reformation line utilizes immense pressure to transform raw fragments into standardized sheets, which, utilizing immense hydraulic pressure, the cleaned fragments are recompressed into dense, reusable glass slabs.
In the forging cycle, the massive press repeatedly strikes the softened metal, reshaping it under immense pressure into a thicker, more compact form. The surface refinement rollers ensure a flawless finish. As the materials pass through, the metal shines, the glass turns. The surface refinement rollers ensure a flawless finish. As the materials pass through, the metal shines, the glass...
Our automated systems precisely manage multiple materials at once. The central arm guides the metal block through the high-speed scanning array.
As the transformed materials align precisely, they head into the fully automated robotic zone, activating the next phase.
Our automated system utilizes advanced AI to scan materials in real time. Only once the green light...
The robotic arms utilize laser guidance to precisely adjust the hydraulic valves, ensuring optimal pressure levels for the titanium alloy sequence.
The automation stage begins. Advanced robotics handle the materials with unparalleled precision. Our multi-angle laser scanners meticulously map the surface structure in real time, ensuring unparalleled precision for every component.
The automated positioning grid ensures perfect alignment for the hydraulic press. Once the components are secured,
the power of synchronization. Watch as the hydraulic presses deliver controlled force, transforming raw materials into finished components. Precision sorting arms ensure every component reaches its destination, accelerating the future of manufacturing. Our automated systems ensure a seamless transition from the hydraulic press directly to the finishing lines, optimizing speed and precision.
Now entering the finishing stage. Advanced automation ensures every component, from metal blocks to glass slabs, meets our exacting standards.
The automated cutting blades ensure uniform dimensions, precisely trimming the metal blocks with unparalleled accuracy.
As the glass slabs move through the polishing line, high-pressure water jets cool the surface, ensuring a flawless...
All materials pass through these final finishing rollers, adding smooth texture and uniform surface quality before synchronized exit.
utilizing our hydraulic press, the rubber sheets are trimmed to exact specifications.
As the materials move through the tunnel, the fine mist removes all contaminants, leaving a perfectly clean surface.
Precision alignment is critical. As the products enter the quality control phase, they undergo intense laser scanning to ensure perfection.
We utilize advanced laser scanning technology to measure dimensional accuracy. As the arm sweep the surface,
Our micro-inspection system scans both metal and glass, providing instant texture analysis. The synchronized hydraulic presses apply the official quality certification stamp.
This entire batch is now approved and moves forward in a unified flow towards dispatch.
The control room monitors display real-time AI analysis of all materials, highlighting the pass or fail results instantly.
Once the hydraulic pressing is complete, the materials proceed to the quality control lab. Here, with full certification confirmed by the sensor gate, the materials now transition directly into the automated packaging phase.
This macro inspection ensures every slab meets our stringent quality standards. The consistent light pattern indicates 0 defects. The system handles diverse materials simultaneously, wrapping metal blocks, glass slabs, and rubber sheets with unparalleled precision.
At the labeling and coding station, automated printers apply crucial identifiers like barcodes and batch IDs to every unit.
Here at the factory, our robotic palletizer stacks wrapped and labeled units neatly onto wooden pallets, which then move directly to the conveyor lane.
The finished hydraulic presses are carefully moved into the high bay racks, ready for shipment to our global distribution partners.
And with final testing complete, our presses are packaged and ready for distribution. The departure line
And this is how modern factories transform raw materials through precision hydraulic engineering from start to finish.